Hello there. Hello. Oh my god. That looks bad if I do something like this and like that. Hello there, green tea. Hello there. How are you today? I think I'm a little bit blurred for some reason. I don't know why. Okay, something like that. I don't know. Okay, whatever. Let's hope that it will be sorted out during the stream. If you are asking, I'm fine as well. Thank you. Thank you very much. Thank you very much. And today, for today's game, I would like to play While True Learn. Let's see if it will graphic display. Okay, so we have like some kind of things. Okay, I'll play, and if I do something like that, will Streamlabs capture the game? It should. It is set to automatically find games. Okay, that looks okay, so let's say accept. It appears that I have some kind of problem because, well, to be honest, I haven't a specific window and I'm looking for this thing and done. Okay, great, fantastic. To be honest, I haven't, this is the first time I have turned on the game because, well, I didn't want to like spoil any surprises or something. So yeah. How loud is it? Okay, so the levels tell me that it's okay. Yeah, I think that the sound should be okay. I hope this sound should be okay. Actually, for me, it's a little bit too loud. I will just turn it down a little bit. A little bit. Do I have? Yeah. Okay. So yeah. So let's see. To be honest, why no better Twitch TV emotes? To be honest, that's a good question because I think I've turned them on. And I think I saw Monka S. That's weird. Okay, I will have to sort that out, but unfortunately after the stream, or maybe right now. Twitch TV. Let's see. Or actually, I think I should go not there. Let's see. Let's go to my channel. Let's pause that. Let's go to chat settings. Better Twitch TV channel. Oh, I have to log in with Twitch. That's kind of bad. That's kind of, yeah. Yeah, that kind of sucks, but I think I can. Yeah, to be honest, Feels Batman works, and I think that's my favorite. Actually, that's weird because for me it works. For me, it works. And not on my preview chat, but okay, you got those two as well. Okay, whatever. I will try to sort that out later. Yeah. Unfortunately, I don't think that's the thing to do during the stream. Yeah, quite unfortunately, to be honest. Yeah, I think I have to configure the Better Twitch TV emotes so that they work. Or maybe because I think that there are better Twitch TV and the other one are like Frank or something like that, and yeah, there is something else. Anyway, let's jump to the game and let's see if I will be able to learn some machine learning, because I've heard that this game allows you to like really learn something about it. The concepts are real in this game, so let's see. Okay, let's go with tutorial. Okay, to become a programmer, you must master your art of turning the computer on. Okay. Press and hold the flashing triangle and drag to connect the power outlet with your PC, screen and keyboard. When it's done, press power button that will appear in the right part of the screen. Congratulations, you are almost a programmer now. Okay, so I have to plug in, okay. To be honest, I don't think it's the best idea to plug in PC first and then the rest of the PC, but whatever. Okay, and that should do it. Time to cross the fingers and turn the power on. Okay, the computer is on. Great, one more step to be a programmer. Continue. Fantastic stuff, that was easy. That was easy. If programming was that easy, it would be great. Okay, so do I do something? Oh, okay. Oh, that sucks. Yeah, that sucks. The bugs are the worst. This is the worst. So, okay, I went to brew a coffee. And it appears that my cat started programming and, well, it's good at it. Well, I think I should buy myself a cat, to be honest. How? Hey, what did you do? Did you do that? Meow. Holy zeros, if only I could understand what this cat has to say. Meow. I guess we'll have to find out a way to recognize your speech. Meow. Okay, so goal: cat speech recognition to-do list. Google it on Cat Overflow. Okay, let's Google it on Cat Overflow. Enter my nickname, Player0. What the hell? Hogsmot. Let's go with Hogsmot. Okay. How to recognize animal speech. Hey everyone, can you believe my cat? The little devil has debugged my code. Again? What? Okay, if you say so. If I say so, to be honest. Cat Overflow, yeah, Cat Overflow sounds familiar. I think I've heard the similar name somewhere. Okay, so the cat, he definitely has something to say, so I decided to make some sort of a system, algorithm, which would help me understand him, give me advice, wish me luck maybe. P.S. I'm not insane, my mom has tested me. Well, my mom didn't. F5. If I press F5, it will go further. So Dr. Coder replies, don't rush ahead of yourself. Making a device that would be able to detect the cat would be a nice start. You can work with video, sound, etc. when the time is right. He11R, or however, hell R? Whatever. Hey, a couple of days ago I've been reading about how expert system can be applied for detecting animals and writing chatbots. The newspaper was called Deep News. I'll be sending you my copies when I'm done with them. That's actually nice. Okay, so I will get some free magazines. Okay, so welcome to your workspace. This is where programming, magic and mostly bugs, is born. To begin, drag an expert system node from the list on the right. Okay, so let's drag that over here. drag the connection line from the starting node on the left to expert system on the right. If you want to delete the connection, place your mouse over the line and press the right mouse button. Okay, so we connect it like that. And I guess I should connect it like that and like that. Click test run to check if the schema works properly. Okay, so test run. Okay. Yeah, looks good enough, I think. So the red and blue squares go in and they go to the right place. Success! Time spent. So yeah, I think it was good. I'm good? Am I good? Do I know how to program? Hey again. I've tried that expert system and it hardly makes any sense. Squares are floating from left to right. Is that what the fuss is all about machine learning? Are you guys actually working there? This is called visual programming, my fellow dude. Yes, this is how it's supposed to work. The expert system analyzes your data input from the camera and checks if there's a cut on them. No, it's not what machine learning is all about. It will get hardcore soon enough. Okay, if you say so. If you say so, I'm up for the challenge. Well, I'm not very good at it yet, apparently. When do I start to actually build a cut translator? Don't rush it, friends. You gotta master your machine learning ninja skills first. I'm working as a freelancer and the amount of contracts is crazy. I forward you some jobs I don't have time for. It will help you get on your feet and earn some cutbacks as well. Also, cutbacks, is that the money I'm using? Cutbacks. Sounds good. So check your email now. P.S. You're still paying for the servers though. Which servers? What are you talking about? So Dr. O'Connor replied, "Hi Hogsmod, noob advice. There's an auto help for each new technology, very convenient. I've turned it on for you now. No need to thank me. But you probably want to change your password. myCatTalks123 is pretty obvious. Yes, to be honest, yes it is. So go to task tree. Okay. So behold the task tree. This is the map of your programming progression in the game. Vertical progression stands for the story quests. Strong password OP, yes. But I think I will. I know the better password. I know a better password. Horizontal branches are optional. Okay. Icon colors stands for different types of machine learning text used in respective tasks. Sounds pretty simple. Oh, so we hope. Okay, so let's go with testing. Applicants. So Spanish school writes to me. Good day, we are from a public school. Summer exams have ended. The results are attached to the letter. Could you process them and predict which of the students will be able to enter the MIT? Okay, let's see. Okay, data. See these colorful geometric shapes? They represent various kinds of data, numbers, letters, elements of images. In modern world, everything can be turned into data, and machine learning is all about sorting and interpreting data. Okay. Long story short, your goal in the game is to transfer data from the left part of the screen to the right. These bars show the minimum amount of data that needs to be processed to complete the task. Okay, so 6 out of 10 has to be processed, so I put the thing over there. And I want green things to go over there and blue things to go over there. And I turn it over there and I do a test run. Is that it? Is that how I become pro at programming or something? Oh! Release the program to complete the task. Okay! Great! Okay, so the cloud was working for apparently 21 seconds, so all in all I got over 300 cutbacks. Nice! Nice, okay. Okay, that was easy. So task type, almost machine learning. So apparently right now everything is almost machine learning. So hello, we have some errors in our questionnaires data. We can't solve the problems by ourselves. Can you please fix it? Okay. So, of medals. Your efficiency is measured not just in money, but with medals too. Medals influence your story progression, while boosting your self-esteem at the same time. Great, I love my self-esteem. To get a medal, your schema has to meet the respective time and node limits. You can improve your results later on. Okay. Sounds nice. Okay, so I have a trash can thing. So in the game, this node destroys elements. Important detail: no matter how many trash cans you place, they will count for one node in the node's limit. Okay, good to know. So real datasets have a lot of errors. Filtering out errors, how do you pronounce this thing correctly? I mean errors? Oh my god, the R's are really hard to pronounce in English, to be honest. Anyway, filtering out these things is a very important skill for all data scientists. Okay, so I can learn about it from the article, but no. Okay, so this time I have to process. Okay, so I will need a trash can and I will put all the shit over there. And yeah. So since we want red and green boxes only, I will throw away blue boxes. So yeah, blue boxes are true, so they go to trash can and the rest goes to output stream too. Let's test that shit. Okay, so far so good, I think. I'm running out of time, but yeah, okay, so I have left enough nodes, I mean not too much. I have also some limit time, so yeah, it's completed. Let's release it. Oh, that's a lot of money. Almost 500 cutbacks. That's great. Okay, so that was easy. Okay, so the next thing is decisions trees. But first, we have to get another errors in DB. So hello, it's us again. We found some new types of errors made by our users. Please update your program. It will be easier if you will use the previous version of the code. Okay, so deep news. Non-neural artificial intelligence. Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. An expert system is a deterministic algorithm which reproduces decisions of a real person. An example this is Elisa, the very first chatbot in the world. It was created in 1966 and talked with the patient using questions similar to the real psychotherapists. Oh, it worked horribly. Oh, that sucks. That's sad. Anyway, sounds good. Okay, so hey, check this out. Custom nodes are special nodes containing your previously designed schemas. Press on the middle tab to switch to custom nodes. Okay, so I go there and drag the custom node, sorting the color red to the workspace. If you want to modify the schema inside the custom node, double right click on it and press the down icon on it. Okay, but I think it will be enough. So this thing gets reds over there, and I should throw away this thing, right? How do I? Okay, yeah, something like that. So I will go back. Okay, so I can. Okay, so there's a layer of abstraction in this thing. Sounds nice. Sounds nice. Okay, so we have a trash can. We have a red or else divide. We put red things over there, and the rest goes to the trash can. Let's see. Let's see. Okay, so far so good, I think. Okay, great. Great. I still have some remaining time, 3 seconds to be precise. It looks okay. Let's release it. Oh, over 800 cutbacks. Okay. So now a decision tree. How to recognize a cat in the picture. Hi, is there any way to detect the cat without using expert systems? It works for texts, but with pictures not so much. Furthermore, the cat just won't sit still. That it does not. Wait. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try Sift. What is Sift? This little devil is way more efficient with pictures. Also works nicely when paired with other algorithms. Okay, if you say so. Or you can use nails or glue or something. Come on, it's just a cat, it won't fight you back. JK, please don't use anything I mentioned on an actual cat. Yeah, that would be brutal. That would be brutal. So processing time. Different nodes have different processing rates. This parameter will influence efficiency of your schemes. Icons on the right indicate the amount of time required for a node to process one element of data. Okay, so in the game, there are decision trees. This node compares output parameters, the sockets, with an element color. If the element color is equal to only one socket color, the element moves to that socket. If an element's color satisfies both conditions or none of them, it goes to a random socket. Okay. The decision tree is one of the basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks someone some questions and chooses the class most similar to the elements. Okay. That is easy, so I don't think I need any further reading or something. Yeah, so this one is easy because if it satisfies, so red things go over there, blue things go over there, and green things go to a random thing. So yeah, let's test run it. Well, the interesting thing is that even though it's called random, in theory, I think the green things can go over, green things can go to the top thing, to the top output stream, and then I would have a problem because there would be too little in the bottom output stream. Anyway, that's great. Okay, so I can go to almost machine learning with Illuminati Origins, but I can go over there. Let's try some optimization. Hi, it's us again. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? We need it to work faster. To decrease and increase speed, click a button on the screen or use arrows. AD. Use space to pause. Okay, so... Oh, that's interesting. So, I guess I have less time. Okay, so I guess it won't be a problem if I do something like that. So blue things will go to trash can, red things will go to the output stream, and well, we will have a random distribution of the green squares between trash can and the output stream. Or, okay, or I can throw in one more decision tree because I had one free node to use. This way I won't have any wrong squares over there. I don't know if it's important or not, but yeah, that looks good. Something like, yeah, that looks... Let's make it a little bit more readable like that, and like that. Like that, okay, and like that. Yeah, that looks nice. So let's increase the speed. Yeah, great. And only, well, 14 seconds. That's a lot of time for a program, but anyway. Oh my fucking god, that's a lot of bugs. Okay, so can I go away from this and see what's there? So I have an inbox, 2 private messages. The history of expert systems. So 1965 can be considered a starting point for the work on creating expert systems. That year, scientists of Stanford Research Institute, Edward Feinbaum and Bruce Buchanan, teamed up with Nobel laureate, is that how we pronounce it? Joshua Lederberg, and began working on a computer system designed to determine the molecular structure of chemical compounds. Okay. And who invented decision trees? So decision tree is one of the automatic data analysis methods. The first ideas of creating decision trees date back to work of Hovland and Hunt in late 50s of 20th century. However, the fundamental work that gave impetus to development of this direction was a book named Hunt Marine and Stone Experiments in Induction, published in 1966. So was it like a year after the expert systems? Yes, okay. That's interesting. So what do we have in CBI? So I can buy aloe, is that how you pronounce it? So that's nothing. Has Skyrim pre-installed, that's nice. That's nice, actually I want Skyrim on the plant. And it's only $50, so like whatever. Okay, so and here I have cat skins, because right now my cat looks like this, but I think I can change it. So only if you find the way, some don't recognize it when they do, some don't ever. What? Get a cat. Oh, it opened my browser. So I have to register in a club. Actually, I don't want it to do it right now. So yeah, maybe later. Let's get back to working. So let's work with MedX. Okay, so MedX. Greetings. Our company is manufacturing all organic natural painkillers. They are used to decrease suffering, mood improvement, and coping with coping, is that how you pronounce it? Whatever. With eating disorders. Okay. Known side effect, including dilated pupils, diarrhea, physical and mental addiction, are caused by human factor. From time to time, our workers pick the wrong plants because they look like medical herbs. We would like you to design an algorithm that would sort your herbs by petals colors. Well, are the workers that stupid that they don't know how to, like, what the fuck is wrong with them? I mean, if a program can, well, distribute the petals by colors, then why human wouldn't? I mean, it seems like whatever. Okay, so we have red going there, green going there, red going there, green going there, but blue goes only over there. Okay, so considering that, so something like that, and any. No. Okay, so my idea is to do something like that. How do I remove this thing? Or I don't, anyway. So, no. No. Okay, let's start with something simple. So, we put it over there and put it over there. No, not like that, but like that. So, red goes to the top thing, blue goes to the middle thing, and wall green goes to both output streams. The thing is that it also has to go to the bottom. So the idea is to use this thing to equally distribute red and green things on both like, you know, output streams. I think it should work, to be honest. I hope, at least. Let's see. Is that how they want me to do it or not? Okay, no. So what was the problem? Okay, so I think that too many things went to the middle one. Okay, I don't want to release it because I want the gold. Okay, so that was bad. Okay, so what if, because even though this piece accepts both blue and green, no, but it will be slow. Like that, and actually not like that, but like that. So blue goes over there. I have 26 blue. Then red and green go over there, and they distribute somewhat equally. Let's see. Or not. Maybe instead of this thing, I will use 2 decision trees because it should be faster, a little bit faster. So I will put blue, red, like that. What? Okay. Blue goes to the next decision tree. Bam. Green goes there, like that, and blue goes there. So the idea is that both reds, so red goes to this decision tree, and it distributes the reds and green how do we call it, squares equally between these 2 output streams. Then yeah, so it distributes them equally between these 2 output streams. Blue goes over there, and then from here it goes over there to the output stream 2. Since we have 26 blue squares, only blue should be enough to fulfill this thing. And in the end we have what? We have green squares, so they go there, they go equally over there and over there, and then from over here they go to output stream 0 and 4. Let's see. Okay, so the problem is that there's little blue squares. So even though... okay, no, that's bad. That's bad, because even though... edit schema. So the problem is that there are 2 little blue squares, so this thing fills up really slow. To be honest, that's quite hard to do it, like, you know, fully, you know, 100% correct. Or maybe the thing is that I should also put a garbage, you know, trash can, so that I don't you know, I don't put too many things in there. No, I don't think so. That's interesting. Let's maybe once again do it with this thing. So I wanted this thing accepts any, and it goes like that. This thing accepts blue and goes like that. Okay. What if... Okay, I have an idea. I take another decision tree. No. I do it like that, and like that. Okay, so idea behind it is that red squares go over there, then over there, and they are equally distributed between these 2 output streams. Then blue squares go over there, then over there, and to the output stream too. Next, green squares go over there. They are equally distributed between this thing and this thing. And then they are equally distributed between this thing and this thing. So, over here we have like 3/4. Yeah, so 75% of green goes over there, and 25% of green goes over there. Let's see if that's how they want me to make it. Oh yeah, it's gold. It's gold because, well, I think that even though it wasn't the fastest algorithm, the thing was that there weren't too many occupants on the output streams. Yeah, I think that was the case. So okay, I did it. That was fun. That was fun. Okay, so I can't do it because I have to first complete this thing, Illuminati Origins. Okay, let's see. So, Strange Man wrote, "Good day, I study ancient manuscripts and books in order to figure out the true story behind the Illuminati secret society. I need to recognize all the triangular shapes in these documents to solve the puzzle. Can you design a program that would do that for me?" Okay, so we have the sift thing. So this node compares shapes. If an element's shape matches the design shape, said element goes to the top socket. The other others go to the bottom socket. Okay, so a scale invariant feature transform is one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. SIFT is very fast and is capable of recognizing simple objects and patterns. Okay. Actually, that's interesting. I don't think I've heard about it. I will have to read about it. Okay, so we have SIFT. So triangles and trash cans. So we go there, and we go there. And bam. Okay, maybe a little bit faster. Okay, great, gold medal. 1017 cutbacks. Okay. Startups. Working for the man feels too easy, boring or soul-sucking? Aim for the sky and become a CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. Okay, if you say so. Like, well, let me quickly turn on the lights. Okay. Oh, and I can see that we have neural networks. Like, they are really close to me. Okay, so let's check the inbox. So, a letter from mom and dad. Hello dear, we remember how you cherish your financial independence, but come on, your birthday is just around the corner. Be a good kid and take this money and buy yourself something nice, will you? We love you very much and we miss you. Do not forget to put a hat on, it's very cold outside. Oh baby, it's cold outside. Take the cash, okay. Oh my god, I'm rich. Oh my god. Cactus protects from radiation. I want that. Oh, and hardware. Okay. So increases sockets processing queue by 3. I don't know what that means. But let's say that yes. I'm rich, I can buy anything. And tambourine increases data transfer speed by 1%. That's actually useful. And then we have Retinium, increases nodes work speed by 1% and increases data transfer speed by 1%. That's also something I want. Okay. And I can buy Cyborg cut skin. Or Viking helmet. To be honest, right now I don't think I want to. I want to use my money. Maybe let's save it for something nice. Pizza Shack. Mama Smith's. Mama Smith's. Oh my god, sounds awesome. Pizza Shack. Hello. Oh my god, it's wet. There's a tea escaping my cup, my mug, by the, you know, the string. That sucks. Okay. Okay. Okay, I think it's okay right now. Okay, so the world is saved from the flood. Okay, so we are honored to invite you to join our startup, world's first AI-controlled pizza place. But our fingers are always stained with flour, and we can't really code because of that. Help us write and implement an algorithm that would be capable to separate orders for round pizza from orders for square pizza shapes. Okay, let's feed the people and become rich. Okay, so startup schema. A schema created while working for a startup does not differ from any other, but there is no solution to startups. A schema just works better or worse, and your future profits depend on its quality. Okay, so the better I write the algorithm, the better it works. Well, that was easy. I mean, that was easy. Your program seems to be working fine. Further testing won't affect your result in this startup. Feel free to stop testing now. Okay, so you're trying to design an AI-controlled pizza place. It serves pizza in round and square shapes. Okay. Why would you make a round pizza box? I mean, what the fuck is wrong with you? I mean, every pizza is round and comes in a square-shaped box. Like, what the fuck? Okay, so the schema you're designing in this is the brain of the pizza robot. It sorts all orders by the shape of pizza that your client orders. These are the users of your startup, in this case your pizza restaurant. They've heard of a new amazing place in town and now they want to grab a slice. These are your clients' orders. The millennials don't care too much about toppings, only shape matters. Oh, it appears I'm not a millennial. Mind the accuracy. If a client gets a pizza they've ordered, they will pay you money and they'll tell their friends about your place. If a client doesn't get what they want, they refuse to pay and don't expect them to return with friends. Okay, one more thing. Clients don't like waiting in queues and they will leave with no hesitation. If your schema is working slowly, the waiting line will get longer. The market is constantly changing, so pay attention to what's going on and experiment with your schemes. And now it's time to launch your first startup. Release. This action deploys the code to the server. From this moment, the startup will work automatically. Yes, let's go. Let's deploy. Okay, let's get to business. This table is your principal source of information about your startups. Press the Next Day button to proceed. Next day. When you switch to the next day, you get the money you've earned or lost, depending on how many users with requests were processed by your schema. Press Next Day to proceed. Hey, look! Your users seem to like what your schema is doing. They're even inviting friends. The cash is flowing. Next. When the hype icon is green, that means your startup is all over the news. Expect lots of new users. So we have a hype on our application. Okay. Great. What does it do? Patch. Okay, so I can patch the thing. And I have this button, and what does it do? Attention, today your shares cost 600 cutbacks. Are you sure you want to sell them and leave the startup? No, I don't want that. I don't want that. It will be huge. I can tell you. This startup is going to be like, you know, the next thing. So I got a mail. Okay, so I can patch if I want. I can patch it. But I don't think I can. I mean, like, it's the faster it can go, because I don't have any other nodes to use other than the Swift thing. So there is no way to patch it. Okay, so let's go to Chicken Escape. Chicken Escape Farm. Hi there, my name is Sarah. I own a small technology farm. What is a technology farm? Our distributors demand supplies of eggs of different kinds, and it takes... Okay, take care. I hope we will see soon, before I end the stream. So, oh my god. I own a small technology farm. Our distributors demand supplies of eggs of different kinds. It takes a lot of time to sort them manually. That's why we've decided to automate the process. We have all the data about egg parameters, but we need an algorithm which will work without human assistance and with high accuracy. That sounds easy enough, so I needed this thing and this thing, and I have to do it like that. Actually, to be honest, I haven't... I mean... yeah, and done. Oh! What has just happened? Edit schema. Okay. No, that's interesting. That's interesting. That's interesting. Because I don't have more nodes and I want accuracy, but what I can do is to do something like that. No. Like that and like that. So now how do I do it? Like that? Yeah, it looks more or less good. I want it to be visually appealing. Okay, so no, that's bad. Okay, So triangle goes there. A square goes there. Like that. Oh my god, that's ugly. Oh my god, I hated that the lines cross. I think I have a little bit of OCD. Let's see if I test run it. Will it be better or not? It was. Okay, that's interesting. To be honest, that's interesting because it appears that the thing that I had to do was to, instead of going, you know, like from top to bottom, since there was a little bit less triangles than other shapes, I had to sort them first, so that the amount of triangles feels faster because they don't have to go through 2 gates. To be honest, that was interesting. That I had to know, like, you know, optimize the algorithm in that way. I really like that. Okay, so we have gold. I'm sorry, let's release it. Okay, so that's a lot of money. So let's go to the next thing, and what's that? Okay, so we have reached the end of the epoch. Click on one of the banners to proceed further in the story. Bronze, silver or gold? What? Gold? I don't know. So, cats, biology and iRobot, that's nice. That's interesting. So I bought something. This should definitely work. Okay, so my algorithm says that cat is a cat. Eureka! The cat has been detected. Okay. Okay. Oh, reinforcement learning? Is that it? Sounds interesting. Okay, so let's go to Rosenblatt Perceptron. Oh, Perceptron, I think I've heard about it somewhere. Okay, so here. So I've managed to make my computer detect the cat. But that beast is a complicated soul. It definitely has more to tell. Maybe it's time to get to go next level and start recognizing emotions. Oh my god, recognizing the emotions of a cat? What? Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll and lava lamps. Also, you can maybe switch to dogs instead of cats. Yeah, that would be great. Decision trees worked like a magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree, you know? Okay, random forests. Error rate. So, and now for something completely different. Perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. The percentage of errors is shown on this icon. Okay, 75. Is it like 75 errors or 75 like, you know, correct things? Use training mode to teach perceptrons and decrease the amount of errors. Can you overtrain them? That would be nice. In training mode, Perceptron reduces the amount of errors while trying to predict the shape of elements. In test run, Perceptron only predicts shapes. Okay. Rosenblatt Perceptron used in Mark 1. this perceptron could recognize only the simple linear dependencies. Actually, I think that all the perceptrons, I mean, the neural network actually is a linear thing in most cases, I think, like the normal deep neural networks. But it was enough to recognize English letters. Okay, so we take this thing, and we can take this thing, and it goes there, there, and we train. Okay, so it learns. Information. The node on the field have reached the minimum margin of error. There's nothing more you can teach them. Okay, so yeah. 20, that's actually a little bit bad. Let's test run it. Okay, so in 45 seconds, yeah, okay, so looks good. So I got 272 money from Mama Smith Pizza Shack. Time is passing by and the market changes. When hype icon is yellow, it means that your target audience is already aware of your startup. Don't expect many new users at this point. Okay, next day. Where hype icon is gray, that means that you've satisfied your target audience. Users starting to leave. That sucks. Watch your earnings carefully. When the number becomes red, it's time to cash out. Next day. Okay, so I think that soon enough there will be a time to sell my first startup for $700. Like, what the hell? Okay, what interesting things I can buy? I can buy a back propaganda poster. Data scientists of the world, unite. Yeah, that's awesome. And fade haircut. Brush your hair with your hand for a perfect hairstyle. Yeah, that sounds like my thing. Yeah. Okay. Nothing more to buy. Okay. So let's go with the next task. So we can go either to another neural network side quest, or we can go to RL. Is that reinforcement learning? Yes, it is. Reinforcement learning. I've always wanted to learn it. To be honest, I wanted to write a master thesis. I want to write a master thesis from reinforcement learning. Hello, we is a society of people who love cats. We want our cats to have all the best. We want cats to drive cars with no humans inside. But cats have no hands, cats have paws. Can you make a car done self-drive? Yours, Dr. Meow, we cats human person. PS, please excuse our grammar. We are not cats, we are human, but we can't type well because we have paws and no hands. Terrible car accident, part surgery. Is why we need a self-driving cars, haha. Okay, if you say so. In reinforcement learning tasks, nodes work in a bit different way. All data is initially unspecified and your task is to recognize it and transmit it to RL agent, the AI. Okay, so in the game, I mean, shift object. So in the game, it gets the unrecognized data on the output and classifies them as either an object or as a road. Objects go to the upper socket, roads go to the bottom. So in real world, Sift is one of the most powerful. Oh, I've already read that. I mean, it was on the previous thing, but it was with shapes. So to be honest, I don't see the difference. Okay, I get it. Okay, I get it. I get the difference. So I think what I have to do is like to put it like this. So from over there, I will get the question marks, and thanks to this thing, Sift object detection, it will say that the question mark is either root or an object, actually root or an object. So let's test run it. Yeah, I think that it should work like this. So the test run was 75 bucks. Tune, what does it do? Oh, training model. On this screen, you'll be training and testing your AI. AI acts basing on data you've been recognizing when building your schema. Okay. The data about surroundings on the road are processed from your schema to machine learning model. Your car won't be capable of learning and detecting obstacles without it. Okay. So target 50 miles per hour. That's a lot. The goal in this type of tasks is to make the AI clever enough to be able to reach the target average speed level. Press supervised run to drive the track yourself using WASD or arrow keys to teach the AI. Be careful, the car sees only objects inside the elite area, green. Okay, so I have to provide as much data as I can. So what do I do? Which car am I? I mean... No. Okay, I'm this car. To be honest, I'm lost. Okay, so we go over there. No. Okay, I think I hit the car. Okay, to be honest, I don't know what I'm doing. Okay, I get it. Okay, I get it. Okay, I know what I'm doing. Okay. Press training and watch the car's AI trying to reproduce your actions. Hope you've been driving safely in that supervised stage. No, I wasn't. I didn't know what I was doing. Evolve. Okay, so your model has achieved the target speed and it also has hit the car in front of it. But why would I care? Press test and enjoy your result. In this result, it's good enough. Try training your car. Testing. Oh! It dodged the car. Oh my god, it's so good. I think we hit just a little bit. Okay. My average speed was good enough. My AI cost... What does it mean, AI cost? Does it mean that it is costing me money or not? Let's retrain it. Let's go with supervised learning because I don't want it to, you know, hit other cars and so on. Let's go faster. Faster. So right now when I see the object, I go left. Then I go faster once again. I think I hit the car. Then we go there and we go right. Okay, and we go faster. I go as fast as I can, and when I see the car, I go bam, bam, and bam. Okay, it wasn't the best thing. Let's train this thing. Okay, so my model has achieved the speed. Let's test it. Okay, it looks good enough. I mean, they don't care whether I hit the cars or not. Let's release it. Okay. So I have huge reward and so on. Okay. But instead of going further, load balancing, I want to go to the dairy products, to the side quests. I like side quests. Okay, so we have the dairy products manufacturer. Hello, my name is Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy in fermentation processes. Alright, off with the fancy words. I want a program that would judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory since we mark them as defective. We have the data, but we need the algorithm. Okay, so we have this thing, and we put it... Okay, that's quite problematic. Or not, it's not problematic at all. Yeah, something like that should be okay. Because, well, I think I should be able to fill in this output stream with only squares and triangles, and furthermore, due to the error, some of the circles will also go to this output stream. Okay. Let's see. My nodes have reached their minimum margin of error. Okay, so the network is trained. Let's test run it. Okay, is it too slow or not? Yeah, oh my fucking god. Okay, so I have to do something about that. Okay, I have an idea. So the idea is to do something like that. On the one hand, this will decrease the error I get. To be honest, I don't know. Let's train it, just so I will train it, just in case. This will train slower, because only a little... Can I do something like this? That I will, replace this thing and this thing? Like that? And this way I will really, quickly... Like that. Bam. Training. That doesn't make sense at all for me. But whatever. Let's test run it. Let's see, but to be honest, I don't know it was a good idea. Because right now I have high accuracy, but my algorithm is too slow. Or maybe not. Apparently not. I don't know. I don't think it should improve. But apparently it did. Okay, apparently it did. Okay, so let's go with Metal Gear Construction. Oh my god. Is it from Solid Construct? I thought that's Solid Snake. Yeah. Okay, that's sad. Hello, we are the Metal Gear Construction Factory. We produce fittings and supply raw materials to construction grounds all around the world. We are especially proud of our high standard of quality. At the moment, we are receiving a lot of new orders and we are running late with the deadlines. An algorithm is required that will analyze the quality of raw material and discard poor quality ore before it leaves the conveyor. Manual analysis takes way more time we can afford. Oh. Okay. So that's what we will need. Oh, that's nice. That's nice. Okay, so the first thing that goes is this thing, I think. Then triangles go over there. And one more decision tree. No. Okay, so I have decision trees instead of you know the other thing. That's not something I want. Okay, so triangles go over there, and down here we will have a triangle sorting system. So red goes there. So red triangles go over there, and blue go over there. Actually, I think first focus on this part. Oh my god. Okay, so the circles and squares go over there. So we want red over there, and okay, what about green? Okay, I can do something like that. And like that. Okay, I will do 100% accuracy. Almost 100 because we have this thing, perceptron. So. Let's start with squares and circles. So, red squares will go over there. Blue go to the trash can. And green circles and squares are equally distributed. So we add another decision tree to filter out green circles and squares. Then we have another decision tree that will sort triangles. First, we filter out red things over there. I don't need that. And blue go to the output stream. Then this thing takes red and green because green are equally distributed between the two. So we put green over there and red in the trash can. And we don't need this trash can. Okay, so let's see if it's fast enough. Let's train the model. Okay, 20%, that's good enough. The nodes on the field have reached their minimum margin of error. Okay, great. And let's test run it. The thing is that since I have one node left, I may have to add one more perceptron so that... oh my god, it's slow. Okay, that was slow apparently. That was slow. So what if I throw it away and put it straight to the trash can, and I throw this thing away? No, I don't throw this thing away. Let's see how this thing works. Because right now it should be a little bit faster, but it's still very slow. Okay. And what if... Yes, that should be a good idea. Good idea might be to put the decision tree... Can I really... all the nodes? Yes, I want to delete all the nodes. So, the first thing I do... I should divide the things between the colors. And then... I should... yeah, that should be a good idea. So, this goes there. So we've got red, blue, red goes up there, and one more decision tree, like that. So over here, we have red and blue, red go there, and red go there, and we need trash cans. So, the red pipeline. Red goes from input stream, goes to the decision tree, then goes up there, and then goes over here. And we want red squares and circles, and we don't want red triangles. Then we take blue thing. Blue thing goes there, and then to the perceptron. And from perceptron we want blue triangles, and we don't want blue circles and squares. Next, what about green things? Green things go equally to both things. So green and green. Green should go over there. So to be precise, I don't need this thing, because green will go over there and over there. I mean over there and over there from start. Can I rename it? No. Oh my god, it would be great to rename the nodes. Okay, so something like that should be enough. Let's train the perceptrons. Okay, so the problem is that it works slow, it blocks. I don't want that. So I will put one more decision tree and one more perceptron. This decision tree will try to distribute green... No, you go there. Okay, like that. Like that. Can I... Yeah, I can scroll back a little bit. Okay, like that should be awesome. Triangles and trash can. Okay, so what is going on? Red shapes go to this decision tree. Then this from this decision tree they go over there, and they and the squares and circles are filtered in for the output stream, and the triangles go to the trash can. What about blue shapes? Blue shapes go to through this decision tree to this decision tree, and this decision tree equally distributes the shapes between these two perceptrons. And we want blue triangles and blue squares and circles go to the trash cans. Great, awesome, fantastic stuff. The next thing is green. What about green? Green is equally distributed between, well, equally randomly distributed between these two nodes. And then from these nodes, node goes to this node. and this node distributes green between these two perceptrons. We accept green triangles and we throw away circles and squares that are green. Let's train my model. I will have to train this perceptron. Okay, so far it looks good because the data flow isn't really bad on the nodes. Let's test run it. Oh, it sucks. What is my time limit? I had 35 seconds. That's not something I'm aiming for. So my algorithm is too slow. What can I do about it? What can I do about it? That's interesting question. To be honest. What if I do something like that? No, I don't think it will help at all. Let's make it faster. No, it was faster, but not fast enough. What if I try to lower my accuracy? Accuracy. Occupancy. So what if I lower my accuracy for the favor of in the favor of time? I don't know. Let's test run it once again and I will try to analyze what goes to the trash can. Okay, no. And what if I try to do something like that? I throw away this thing. No, actually I want this thing. But I throw away this thing. Any and any. Or maybe red and green? Let's see. So right now I want to decrease the accuracy by removing this thing. Okay, it was faster. And the accuracy was still 80%. So what I did was to, well, I removed this decision tree so that some green triangles were going up there. Actually, yeah, some green triangles. So I accepted all green squares and circles. And apparently it wasn't a problem that I accepted these things. And what if I right now remove this thing and put it over there like that? So I will have lower accuracy. Oh, and it blocks. Okay, maybe what if I analyze the input data? So I have a lot of blue triangles. To be honest, I have a lot of blue things. Okay. Let's put it like that. Let's throw away these connections. So, we take out the triangles. We assume that the triangles, red triangles are bad, and blue triangles are good. Actually, let's put it like that. And let's put it in the middle. I'm sorry. Okay. So we put triangles over there. And bam. And the rest goes over there. And red goes over here. Blue goes over here. No, it will be slower because all the data has to go through this thing and it's slowing it down. Yeah, I've already had that. Yeah, because let's clear this thing once again. Because 3 perceptrons actually cost the same time. No, not like that. Actually cost the same time as like that. Any and any. Okay. Triangles, triangles, trash can. Let's train this thing. So the thing is, okay, this thing doesn't block. This thing doesn't block. This thing doesn't block. And let's test run it. That's actually pretty interesting. Okay. So I have to go 5 seconds less. The thing with perceptron is that it is slow. But adding one, as far as if I'm counting correctly, one perceptron, adding one perceptron over here does not change the results. I mean, if I no, not this thing, but perceptron. Okay, let's test run it once again at a slower speed a little bit. So let's analyze all the bad inputs that travels. So we had a green triangle over there. To be honest, that's quite interesting. What if I add one more decision tree? Which filters out all the green stuff? Wait a minute. I want blue stuff. Oh my fucking god, I'm so fucking retarded. Okay, we have a lot of blue, so we can lose some of the blue. So we go like this. Okay, right now. Let's increase the speed. Okay, that was a little bit faster. And I want one more decision tree. So like that. So I have a lot of blue things. So, yeah. So blue things can get a little bit slower. Yeah, like that. Okay, so this decision tree has some problems. No, it was slow as fuck. Actually, that's quite interesting. Okay, I know the why. I think I know why. To be honest, I'm getting a little bit exhausted. How do I make it work faster? How do I make it work faster? Okay, so without this thing, how are we doing? Test run. Oh my fucking god, I'm so fucking retarded. I don't want this thing. I think. At least. Can I do something like that? So this thing looks bad. Okay, and this thing lags. So no. That's bad as fuck. Let's test run it once again. I fucked it up because I want any and any test run. Oh my fucking god. 0.9 second. Edit schema. What if? Because I have one more thing to use. Okay, so the idea is, in theory, I think that in theory, all the things that go to the trash can, they aren't actually counted. I mean, they wouldn't go to the output stream anyway, and the data in output stream determines whether I'm done or not. I'm sorry. So, the thing is, what if, instead of putting some things in a trash can, I put them over there. This way, the 20% of the triangles that go to the trash can, actually, yeah, 20%, yeah, it's error rate. So 20% of triangles that go there will actually land over here, and that's good, I think. But that's only 20%. Let's try that in the meantime. That's only 20%. The other thing is that I'm thinking. Okay, let's test run it. Because 20% of the triangles go over there. On the other hand, that's still 0.9. So let's try doing it like that. So you go over there and you do it like and you do it like that. Because on the other hand, in this thing, 20% of squares and circles go to the trash can. No, I fucked it up. That was stupid. Like that. Test run. The problem is that this works slow. It blocks from time to time. No, that's still 0.9. Okay, because one thing is for sure, I have to put decision tree first. Why? Because perceptron is too slow. So I want the slower process to be running concurrently. My god, am I really that stupid? What the fuck is wrong with me? Like that. Actually, was it the problem that some of the output wasn't going to the trash can? Let me test run it. No, I don't think so, but it's still 0.9 second. Okay, so I have low accuracy. Why? I know why, because blue squares and circles go over there. And blue triangles, okay, like that. Triangles go over there. Then we take blue triangles and put them over there, like that. And I don't want this perceptron. Yes? Yes, I think yes. And red goes to the trash can. Test run. Is it better than putting this thing over there? I don't know. Apparently it is. Apparently it is. Oh my fucking god, I'm so fucking stupid. Or maybe I'm just exhausted. Okay. Okay, I did it. Okay, I did it. Oh my fucking god, I have to sell it. Sell! Nice. What I can buy on Cutbuy? Can buy cut skins. Let's go with the Viking cat. Oh, nice. Oh, I can change them. Anyway. Oh my god, fucking god, I'm so... to be honest, I don't know if I'm stupid or something. But from time to time this game was... You know, this game was... Enter save in Hogsmod. This game was hard from time to time. I mean, I didn't expect it to be really, that hard. Yes, I want to exit the game. Anyway, yes. Yes, thank you very much. Thank you very much for today's stream. It was nice, to be honest, I don't know if I can call it programming, But yeah, like this game was pretty interesting, to be honest. I really like that. But it was quite exhausting, I think. But I don't know. Anyway, I hope that you liked it. I will try to stream tomorrow, but I think that maybe I will do something in the evening, so I won't be able to stream. But if not tomorrow, then I will stream on Thursday. Yeah, Thursday. It was pretty interesting. You think so? Okay, that's great. That's great. Yes, I hope I will be streaming. I will be able to stream one more time this week. Yes. The next thing is that I'm also planning to start another stream. I don't think I will finish the game before that, or maybe I will. Anyway, it doesn't matter right now. It doesn't matter. Yes, it doesn't matter. Because I'm preparing another stream and it's a surprise. I know that Green Tea already knows what it is. But yeah, it's a surprise. A little bit of surprise. So I'm still working on it. So I hope it will be done by the next week. It will be done by the next week. And yes, I think that's everything. Yes, I think that's everything. So yeah, once again, thank you very much for being with me today. I hope that you had fun. And yes, I hope that we will see each other one more time this week. And thank you very much. No, it's not a problem at all. I mean, if you had to, then that's not a problem. I'm really happy that you like the stream. So yeah. Oh, and if you want, there is a VOD. VOD? Yes, VOD. Okay, this bot was lagging a little bit. So yeah, there's a VOD command. You can go and check out the past streams. I have to publish Gothic streams because I have them uploaded, but they aren't published yet. So yeah, that's one thing. And yeah, I hope we will see each other this week one more time. Thank you very much, and bye bye.